Astronomers have discovered two colossal chimneys funneling material from the vicinity of the Milky Way supermassive black hole into two huge cosmic bubbles. The giant bubbles were discovered back in 2010 by NASA's Fermi Gamma Ray Space Telescope. One bubble stretches above the plane of the Milky Way galaxy's disk and the other below it. Looking side-on, they form a shape akin to a giant colossal hourglass that spans some 50,000 light-years with about half the diameter of the entire galaxy. You can think of these gamma-ray bubbles as sort of giant burps of material from the central regions of our Milky Way, where its central black hole, known as Sagittarius A star, resides. Now, the European Space Agency's XMM Newton Space Telescope has discovered two channels of superheated X-ray material streaming outwards from Sagittarius A star, and finally linking the immediate surroundings of the black hole and the bubbles together. The study's lead author, Gabriella Ponti from the Max Planck Institute, says astronomers have known that outflows and winds of material and energy emanating from the galaxy are crucial in sculpting and altering the galaxy's shape over time. These are key players in how galaxies and other structures form and evolve throughout the cosmos. And our Milky Way galaxy gives astronomers a nearby laboratory to explore this phenomenon in detail, letting them probe how material flows out into space from the black hole. The authors used data gathered by XMM Newton between 2016 and 2018 to form the most extensive X-ray map ever made of the galaxy's core. The map showed these long channels of superheated gas, each extending for hundreds of light-years, streaming above and below the plane of the Milky Way. Astronomers think that these act as, sort of exhaust pipes, through which energy and mass are being transported from our galaxy's heart out to the base of the bubbles, replenishing them with new material. The finding clarifies how the activity occurring in the core of the galaxy, both present and past, is connected to the existence of the larger structures around it. The outflow could be a remnant of the galaxy's past, from a period when activity was far more prevalent and powerful. Or it may prove that even quiescent galaxies, like those hosting relatively quiet supermassive black holes with moderate levels of star formation, like the Milky Way for example, can still boast huge energetic outflows of material. Mind you, despite its categorization as quiescent on the cosmic scale of galactic activity, previous data from XMM Newton has revealed that the Milky Way's core is still quite tumultuous and chaotic. Dying stars explode violently, throwing their material out into space. Binary stars whirl around one another and Sagittarius A star, a monster black hole containing the equivalent of 4.3 million times the mass of our Sun, which is lying there in wait for incoming material to devour, later belching out radiation and energetic particles as it does so.